Hello class. For this lesson, for part 4, we're going to look at force time graphs. At the end of this lesson, you should be able to plot force time graphs and you should be able to calculate impulse from force time graphs. So let's start. So you can plot a graph of force in the y-axis and time in the x-axis, and that can tell us a lot of things about what's happening. The area under the force time graph, so FT, that's just a shortened version of force time graph. The area under the graph for in this case is the impulse. So if you calculate the area, you will get the impulse. So let's do some examples and see how this is done. Example 7, a constant force of 80 newtons acts on a 10 kilogram block for 5 seconds. A, draw a force time graph for the block. So what you do is, so this is not going to be an accurate drawing because I'm just drawing this on a mouse. When you are drawing this, always label the axis. So y-axis, that's force slash the unit, Newton. X-axis, that is the time, slash the unit. In this case, we are using seconds. There's a constant force of 80 newtons, and this acts on the block for 5 seconds. So at a time from 0 and 5 seconds, there is a constant force of 80 newtons. So you just draw a constant force, which is a horizontal straight line, and that's pretty much it. And you're done. B, what is the impulse exerted on the block during this time period? Now we want to know the impulse. The impulse is the area under the graph, remember? You can still calculate the impulse using the impulse formulas. So let's do it both ways. So let's use this formula, and then force is 80, time is 5, and you will get 400 Newton second as the impulse. Now let's use the second method, which is using the area under the graph. And you can see the area under the graph is a rectangle. So it's basically the area of a rectangle, which is length times breadth. Length of this rectangle is, let's say it's 80. Breadth is 5. And that will also give you the same answer, which is 400 Newton second. So you can use two methods to calculate impulse, but when you are given a force time graph, it's much more better to use method number 2 than number 1, because number 1 sometimes can be used in certain cases. Like in example 8. Let's do this question. Now let's say the force acting on the 10 kilogram block is not constant. Okay, so keep this in mind. The force is not constant. It increases from 0 to 80 at a constant rate. So that means it goes up from 0 to 80 at a constant rate. But the force is not at a constant value. The force doesn't stay the same value. This happens for a duration of 5 seconds. Draw a force time graph of the block. So let's draw that really quickly. Okay, so the time goes from 0 up until 5. The force increases from 0 and then until 80 for 5 seconds. So let's draw. So then when you draw the force, it should be a straight line like this. Now it's no longer a constant force. B, what is the impulse exerted on the block during this time period? So if you use the first method from before, which is this formula here, and then the time is 5 seconds, okay? What about the force? Which force are you using? Are you going to use 0? Because in this case, the force changes from 0 up until 80. Are you going to use 0? Are you going to use 80 for the force? Or are you going to use the one in the middle? So that's why this formula doesn't work, especially in this case. When you have a force that is not constant, you are not able to use this formula. And that's why the second method is better in this case, which is the area under the graph. So let's do that. So the area under the graph in this case, it has the shape of a triangle. So the formula, we use the formula of a triangle as well. Half time base time height. What's the base? The base is this length here, which is 5. What's the height? The height is this height here, which is 80. And so the answer is 200, and that is the impulse. Let's do another example, example 9. The graph shows a force time graph for an object. Find the impulse exerted on the object. So again, you are given a graph and not a lot of other information. How are you going to find the impulse? You find it from the area under the graph. Now the graph is a trapezium. You can just straight away use the area of a trapezium, or what you can do is you can divide this graph into two different areas. So area A, which is a rectangle, and area B, which is a triangle. So you can just divide them into two. So this is what I'm going to use as my working method, right? So it's area A, which is the rectangle, plus area B, which is the triangle. So for area A is a rectangle, so it's length time breadth. That's the formula. For area B, it's a triangle, so it's half time base time height. So let's put in the numbers. Area A has a length of 3 and a breadth of 2. Okay, as for area, that's area A. For area B, the base is this one here, 3, 4, 5. So it has a base of 2 and a height of 2 as well. So 3 times 2 is 6 plus half times 2 times 2, that is 2. And the final answer is 8 Newton second. Let's go back a bit to our second lesson where we talked about this part here. Why, when a plate is dropped on a concrete floor, there's a big force and it breaks, but when a plate falls onto a soft pillow, it doesn't break. There's not a lot of force, right? So we can use the force time graph to show what actually happens during these two cases. Now, when the plate is falling, so at first it's moving at a certain speed. So both of these are moving at a certain speed because they're both the same object and they fall at the same height. They have the same initial speed, and then when they stop, when they hit the object, they stop. So their momentum becomes 0. So in both of these cases, the change in momentum is the same. Now, because the change in momentum is the same, the impulse is the same. So both of these plates give the same impulse to these two objects, right? So if the plate is giving 100 newtons per second impulse to the concrete, the other plate will also give 100 newtons per second of impulse to the pillow as well. Okay, so impulse is equal to change in momentum, and because the change in momentum for this plate are the same when they hit the object, so they have the same impulse. Except that the way that the impulse is given is different. So for the concrete case, you can see this is what's happened. It hits the concrete floor very quickly. So there is a short collision time, and because of that, the force is large. Okay, whereas in the case of the pillow, it takes a longer time for the plate to reach a speed of 0. It takes a longer time for the plate to stop. So it has a longer collision time. And what that's going to do is that it's going to decrease the force. So the area of the graph is the impulse. The impulse given by both objects are the same. It's just a matter of how this impulse is distributed. If it occurs at a short time, then that means it needs to have a large force to deliver the same impulse. If it occurs at a longer time, then the force has to become smaller in order to have the same impulse. So these two graphs explain why the plate breaks for the when it hits concrete, because it produces a large force, and why it doesn't break when it hits the pillow. So to summarize, you can draw a force time graph, and the area under the force time graph gives you the impulse. If you have a short collision time, normally it will cause a large force. If you have a longer collision time, normally that will cause a smaller force. And for the next lesson, we're going to look at something that's called the law of conservation of momentum.